Very good evening, dear all. Welcome to Gradeup. Atul, very good evening, dear. So, dear students, this is the session which is for NLC GET 2020, and this today's session we are going to discuss some of the very important question on the production engineering part 1. Definitely we have planned 3 sessions regarding to the production and material science. Hi, hello everybody, namaskar. Come on, join this session, like this session. Good evening dear all, good evening. Welcome to Gradeup, the India's largest e-learning platform. Okay, very nice. So dear students, in the today's session, of course, this is a 500 question, very top question series. 500 plus question series we have planned for you people only. And today is the subject production engineering part 1 we are going to discuss. So shall we start? Come on, have some movement in the chat box. So of course this is kind of marathon type series, we'll be having question series. So fastly you have to respond in the chat box. Nitish, very good evening dear. Adnan, Sandeep, Raminson, hi. Sam, Shrikant, Atul, hello Amul, Dayakar, very good evening dear. So all of you are welcome to the Gradeup. And see dear students, this is about me. I am Onkar, having more than 10 years of experience for teaching GATE and ESC and all the other competitive exams. I have mentored more than 10,000 students, and my area of expertise are the production engineering, fluid mechanics and industrial engineering. So are you ready? Are you with me? So that we will start the today's session. Okay, we will start. Vemuri, definitely we are going to start. Fine, very nice dear students. So this is the first question for you. Consider the following characteristics. There are 3 characteristics they are giving. So dear Sachin, Tamil Sachin, this is the class for mechanical engineering. Okay, tell me the cutting edge is normal to the cutting velocity. Okay, this can be only happen in case of the orthogonal cutting. The cutting force occurs in the 2-directional. Yes, 2-dimensional cutting only measure cutting force, that is FC, and the thrust force FT. The cutting edge is wider than the depth of cut. No, it is not requirement to have the machining as a orthogonal. Okay, so they are asking the characteristic applicable to orthogonal cutting would be include. Yes, tell me the answer. Which of these statements are correct? So dear, for the machining to be the orthogonal one, which is the correct? Adnan, please check out dear. See, it is not necessary that cutting edge is wider than the depth of cut. This is not the requirement. The basic requirement for the orthogonal machining, that is, see, if I take the example of the step turning, you can see this is the tool here. Okay, so this is the cutting edge of the tool and the velocity vector, the angle between these two is 90 degree, or they are perpendicular to each other, that is correct, and that will result into the 2 cutting forces, one is FC and other is FT. Yes, so option A is correct. 1 and 2 are correct. Please, 1 and 2 are correct. Sam, that is correct. Ramisman is correct. Mukesh Pal, correct. Jitendra Kumar, very nice. Take the next question. In oblique cutting of the metals, the cutting edge of the tool is, just now I told you, say, now you take the example, same example with this kind of tool or arrangement. You are going to have the step turning, but like this. So your tool is here. Okay, now you can see the cutting edge and the velocity vector. The angle is not 90 degree, it is other than 90 degree. So it is in, yes, it is inclined at. Yes, Sandeep, very good. So in oblique cutting of the metal, the cutting edge of the tool is inclined at an angle less than 90 degree to the direction of the tool travel. So this is the angle here we can have, which is less than 90 degree. Yes, D is the correct answer. Very good, very good. Neeraj, very good. Anurag, very nice dear. Nehal, very good. Nice. Take the next question. Which of the following is an example of orthogonal cutting? Orthogonal cutting. Now the definition of orthogonal and oblique is much clear. So just now I have the pipe turning. Say pipe turning. We have possibility to get the orthogonal turning only, not the shaping, drilling, milling are. Shaping, drilling, milling are what? Oblique cutting operations. They are oblique cutting operation. Only this turning. See here. This is the turning. Okay. So B is the correct answer. B. Tapan, very nice. Anurag, very nice. Balaji, very nice. Chetan, come on dear. Come on. Yes. Very nice questions. Definitely today we are going to talk about this metal cutting. Yes. Yes. Very good. Come on. Join and like this session. Very nice, very nice. Take this question, take this question. The cutting tool that performs the orthogonal cutting, which of the following tool is performing the orthogonal? See, drill is oblique, helical milling cutter oblique, single point cutting tool actually oblique. Okay. The broach, see here, the broach is performing the orthogonal cutting operation. Which cutting tool? That is the broach. The broach is the correct answer. Broaching. Broaching, sawing, see, broaching, sawing, parting off. Broaching, sawing, parting off, all are performed the orthogonal cutting. Very nice. So B is the correct. So the single point cutting tool turning, that was this kind of cutting is there. That is simply like this. Knife cutting, knife cutting. So this is the only the case of orthogonal. Otherwise, the turning is also oblique. Please remember this. Broaching is always orthogonal. The portion of the tool which can be cutting edge formed. The portion of the tool. Tell me. The portion of the tool on which the cutting edge is formed is known as cutting edge. See, this is the cutting edge. This is the single point cutting tool. If I show you, this is the cutting edge where it is forming. So dear, it is formed on the shank. What is the answer? Not flank, it is on the shank. Body of the tool. Okay, main body of the tool, that is the shank. A is the correct. Varma Ajay, very good, very good. It is on the shank dear. I hope it is clear. Yes, next question. Tool signature in the ASA system comprises of how many elements are there? If I take the ASA system, any system, say back rake angle, side rake angle, then relief angle, end relief, side relief, then end cutting edge, side cutting edge, and the nose radius, that is the linear dimension are how many? How many? How many? 1, 2, 3, 4, 5, 6, 7. So 7 elements. Yes, very good, very good. Very good. So D is the correct, D is the correct, D is the correct. Very good. Take the next. The tool signature in ASC system, the nose radius is indicated in. See here where the nose radius is indicated at the C. This is starting position, this is the ending position. At the last, nose radius, that is all these angles are in degrees. Okay, and the nose radius, that is the linear dimension, which is in millimeter. Okay, the last, where it is in the tool signature, the nose radius at the last position, dear students, at the last. Very good. Bhupesh, very nice. Kiran, very good. Kuldeep, very good. I hope you are getting the questions. Shall I go for the next? C Chennai, that is correct. C Chennai, correct. Jitendra, very nice. Take the next. The angle on which the strength of the tool depends is. Please tell me the answer. Now I am showing you. See, this is the tool. And this is our back rake angle. This is a leap angle. This is all cutting angle. Tell me, and this is our leap angle. Now tell me, the angle on which the strength of the tool is depends. Tell me, the angle on which the strength of the tool is depend here. So please remember dear, this rake angle is very important. This rake angle. Okay, this rake angle alpha. If you go on increasing the alpha, definitely the tool is become weaker. The strength carrying capacity, load carrying capacity definitely goes on decreasing. And of course, see, if the alpha goes on increases, this leap angle is getting affected. It is become very less. Okay, and the tool becomes weak. So tell me what is the correct? Not the leap angle that decides. It is the rake angle, dear. It is a rake angle. See, the angle which you are making when you are grinding the tool, if you go and have the geometry on the tool, so this angle, you are not making the leap angle, you are making the back rake angle. That is why it is getting the leap angle. Okay, so yes, rake angle is correct. Whenever you ground the tool, go on have the geometry on the tool, it is the rake angle that you are providing, not the leap angle. So dear, please try to understand the difference. Even though it is interdependent, but it is again dependent on the rake angle only. So A is very correct. A is correct. So Ajju, it is correct. Next question. Tell me the answer. Nehal Ahmad, tell me the answer. The shear angle is angle between. So this is our famous diagram in the cutting operation. This is the chip. This is the tool. And tell me the shear angle. So the angle between the cutting velocity vector and the shear plane, it is known as the shear angle phi. So dear Bhupesh, leap angle is again dependent on how much rake angle you are providing onto the tool. So ultimately the rake angle is the main thing. Okay. So when this leap angle is going to form when you are making the alpha, okay, and when you are having the relief angle. Please remember. So relief angle is not having that much value, 3 degree to 10 degree, that is more than enough relief angle we are using. But this is very important here. This is the decision making angle. So shear angle is the angle between the shear plane and the horizontal. That is correct. C is correct. Very good. This is C. This is our phi shear angle. Very Ganpati. Very good. Shear plane and the jobs are no. D is not the correct. So shear angle is the angle between the shear plane and you can take the horizontal or the cutting velocity vector VC. That will be your shear plane angle phi. Take the next question. For the cutting of the brass with a single point cutting tool on the left, the tool should have. Tell me. Come on, very fast. What is the answer? So for cutting the brass is generally cut with which tool angle? Yes. Come on, give me the answer. Bhupesh, negative angle we are using for the ceramics, not for ceramic, carbide tools, which are very high, very good high compressive strength, but very low. They are very weak in tension for such a materials. Yes, zero rake angle in case of the brasses to get the good surface finished here, because brass is quite brittle material, and to have the good surface finish we are going to have the zero rake. C is correct. Very good, Dharmendra, Naveen, Bhupesh. Very nice dear, very nice. Anurag, very good, 0. Go for the next question. Nose radius is expressed in the nose radius. Just now I told you generally it is a linear dimension. Don't forget, it is a linear dimension here. So that is the reason why it is not changing in American Standard of Society for designation the tool and not in the orthogonal rake system. In ASA and in ORS it is same only. It is not changing because it is a linear dimension. It is not the angle. Very nice, very nice. Come on, join this session, like this session and subscribe to this Gradeup channel. Dear, tell me which one among the following is the slowest speed operation in the leg. Nice, dear, nice. Avasthi, yes, it may be in inches, in millimeters. Generally inches we are using in the ASA system and ORS we are using in millimeter. Yes, dear, tell me which among the following is the slowest operation, dear. Slowest operation. Turning, thread cutting, taper turning and knurling. Tell me. Yes, yes, yes. Very nice. All are correct. All are correct. Balaji, please check your answer. See, the knurling, even though it is small operation, it is not quite so critical operation. Okay. You are simply making the grip. So thread cutting, dear, this is very, very critical operation. Yes, it is the slowest operation on the leg. Thread cutting, thread cutting. Not even taper turning, not even knurling. It is a thread cutting. Very nice, very nice. Come on. Very good, Kuldeep. Not D, dear. It is B only, thread cutting. Okay, take the next. When the machining a hard and brittle metal like cast iron, the type of the chip produced is, yes, dear, cast iron is a very hard and brittle material. Definitely it will lead to the which kind of chips? Tell me which kind of chip? Continuous, discontinuous, fine, continuous chip with the built up edge. Come on, dear students, give me the response. Yes, right, discontinuous. See, dear students, brittle materials, whenever the crack or the energy propagating wave reaches very fastly onto the work surface, it is only possible with the material having the low toughness value, that is high brittleness. Yes, so cast iron is a brittle material and it is definitely giving us the discontinuous chip. Very good. Come on, Ankur, very nice, dear. This is the correct answer. B is correct. Anurag, very nice. Very good. Nadev, Kurade, Ankur Kumar, very nice. Take the next question. Now tell me the answer for this. Single point thread cutting tool should ideally have. Please understand this question very nicely. The single point thread cutting tool should ideally have. Tell me the answer. Come on, fast. Jitendra, Nitish Kumar, all are saying A. So you are saying like this, that is during the thread cutting I use this tool like this with the zero rake angle. That is quite okay. That is for our convenience we are using. We know what are the advantages to use the tool with this zero rake angle, so that chip is lifting and it is curling down back onto the rake surface. So the chip is not moving along the side wide so that it cannot damage the produced thread, isn't it? That is okay. I don't agree with that. So sorry, I am agree with this, but ideally speaking, dear, this important. Ideally single point thread cutting tool should I am saying to student, it should be the positive rake. Please remember, B is the correct. Ideally speaking, it should be the positive rake, but in reality when we use this tool with the generally zero rake angle, yes, Kuldeep, very nice. Raja, very nice. Ramisman, very nice. So B is the correct answer, dear. B. But general way we are using straightforward way, that is the zero rectangle. Next question. Next question. A very famous equation. Taylor's two life equation. Taylor's two life equation. What is the answer? What is the answer? Taylor's two life equation. Oh my God. Who says B? Yes, come on, give me the answer. Taylor's two life equation. Very good. Vt to the power n is equal to constant. Okay. Yes, very good. Very nice. Very nice. All of you, very good. A is the correct answer. That is a very popular, very famous equation. That is the Taylor's two life equation. Okay. He spent his entire life in the experiments to have the relationship, okay, between this cutting velocity, time, and this Taylor's strain hardening Taylor's two life exponent. Okay, and he was very interested in the empirical relationships, to develop the empirical relationships. Okay, and finally he developed the relationship, that is Vt to the power n is equal to constant. Very useful equation. Okay, in the measurement of the cutting tool life. That is okay. Vt to the power n is equal to constant. Next question. The function of the chip breaker in the cutting tool is, the function of the chip breaker, dear. We are interested to have the chip breaker. So here I have provided this chip breaker. Now why should I provide this chip breaker? This is my chip. Okay. Tell me why? To get long chip, to break the chip into short segment, to remove the chips from the bed, and none of the above. Tell me which is the correct. Dear students, generally speaking, the discontinuous chips are favorable one, because they are very easy to have the disposal of that. But when you talk about this long and continuous chip, the handling of the chip, the disposal of the chip is quite difficult here. And that is the reason why we need to break that chip by using this chip breaker. This is our chip breaker I have shown here. This is a chip breaker. So the main intention behind is that to break the chip into short segments so that the disposal, handling is quite easy. Right? B is the correct answer. B is the correct answer. Balaji, please check. Madhumita, not C. Not C. Okay. This is quite independent thing, dear. Okay. So this is not a big deal during the machining. So it is after machining, you can, from the bed, you can have using the wire brush and all, you can clean that. That is not big issue. But here during the operation, this is the very thing. B is the very important thing. I hope it is clear. I hope it is clear. Next question. Very nice question. An ideal tool material is one in which has very long life, has same life at all cutting speeds, produces no heat during cutting, and produces smooth surface finish. Tell me, what is an ideal tool material? Ideal tool material. Come on, answer the question. So an ideal tool material. Very nice question, dear. Nitish, very nice. Nitish, Sunil, very nice. Adnan, very nice, dear. Sam, very nice. Nehal, very nice. So dear, please remember that it is not the matter that so how much speed you can use for that tool, okay, or how much tool life you are getting, but the thing is that it have the consistency in the tool life at the various speeds, please remember, not only the long life, Ankur, please, not only the long life we want, but we want the same life Even though if I machine with the low, medium or high cutting speeds, it should not deviate from the life. Okay, Chahat, so very good dear, it is option B is very much correct. The ideal tool material is one in which it has the same life at the different or all the kind of cutting speeds. Very nice, B is the correct answer, B is the correct answer. Next. Which of the following uses a single point cutting tool? Tell me. Drill is having 2 cutting edges. Reamer is also having the even number of cutting edges. Milling cutter n number of teeth. Tell me what is the correct answer. Sandeep, very good. Sandeep, very good. Bhupesh, very good. Anju, Sunil, very nice dear, very nice. Yes, very good. Drill having 2 cutting edges, reamer even number of edges. Okay. Milling cutter, you know, that is very simple. Parting tool. That is correct. Very nice. Very good. Take the next question. In the metal cutting operation, the approximate ratio of the heat distribution among the chip, tool and the work is in order of. Very nice question dear, answer it. Very nice question, answer it. Tell me, very easy. Such a kind of question you are expecting in the exam only, NLC. So the level of the questions like this only, okay. So you know very well that the maximum amount of heat in the metal cutting operation is carried away by the chip. Okay, then by the workpiece and then by the tool dear. Okay. Heat carried away by, very nice, 80 as to 10 very good dear, all very nice. So see, such a kind of questions we are expecting. Yes, this is the level only. See, yeah, we are not going to in that particular value, but we know that Shubham, maximum heat is always carried away by the, if I tell you the exact value, it will be the 85% by the tool, 10% from the tool, 85% by the chip, 10% from the workpiece and 5% from the tool. That is correct, Shubham, if you want the exact values. Dear, please, no fear. We are here. Come on. Take the next. Tell me, very nice question. Sai Ramesha, very good. Thank you so much, Chetan, Akash. Yes, dear, definitely we are going to share it. Yes, dear, all these sets are there. Ready, definitely tomorrow I will be discussing on the forging, that is metal forming processes. Don't worry, casting, welding, all the questions. So today importantly I discussing about this metal cutting. So we are having the 3 sessions for this production. Definitely we are going to cover that forming, casting, welding, okay, industrial engineering, material science. Very good. So whenever see the grain size is large, the material having good ductility, material having good formability, so it can give you us the quite good cutting, okay. Good machinability will get definitely, and that time the tool life is of course very nice. So dear, grain size of metal when small, the material become, whenever the smaller grain size, the strength of the material is high, hardness of the material high, So definitely the tool is expecting the lot of amount of cutting forces, and against that it is definitely having the lesser tool life, dear. Raja, not B, dear, not a B, dear, not a C also. Tool life is generally better when we are having the workpiece with the large grain size. I hope it is clear. Large grain size results into the good ductility, which results into good formability, which results into the good cutting, less forces. It may be Chetan, so Chahat, so definitely we, yes dear, definitely we will plan. So do follow me on the Gradeup app you are having there. So you can follow me on the Gradeup app, dear. So definitely we can plan something for that also. So take the next question. So but see, this level is quite same only. Don't worry about that. Tool, tell me the answer for this. See, cutting velocity, definitely when you are using the cutting velocity, so definitely tool life, no doubt you are getting all the things very good. MRR, you are getting good material, finish surface, you are getting good. Okay, but the wear and tear of the tool is quite high. Okay, please remember this. So tell me, very famous equation, dear student, that is Ernst and Merchant. Okay, this is the equation, that is 2 phi plus beta, that is this is the shear angle, beta is the friction angle, plus 2 phi plus beta minus alpha is equal to 90 degree, that is pi by 2. 2 phi plus beta minus alpha. Yes, definitely. So Gradeup, definitely there are the series of minds also going on the production engineering. Okay, you can join every morning at 9 a.m. We are having this revision series for the production engineer, which is conducted by me only, right? So for all the subjects there are the series, dear. Just come and join and have the advantage. Okay, so that is correct. 2 phi plus beta minus alpha is equal to 90 degree, not 45 degree. So this is the Merchant analysis. Okay, Ernst and Merchant. Okay, the second solution, if they want, this is the first solution. What is second solution? That is 2 phi plus beta minus alpha, which is the machining constant Cm. That is the second solution of the Merchant. Okay, because the first solution quite suitable for the synthetic materials, but we are more interested in the cutting of the harder materials like steel, ferrous materials. So that is the reason why he again revise this theory and give the second solution for this Merchant's theory, that is the 2 phi plus beta minus alpha is machining constant Cm. Okay, so you just have log into this Gradeup app here. You definitely get all the schedule of the classes which are going on. Okay, now tell me what is the correct relation for the Lee and Schaeffer theory, Lee and Schaeffer analysis. So dear students, 1 mark question can be asked, which was asked in the ISRO. Which one of the following theory is based upon the slip line methodology or the plastic deformation criteria? So dear, this is the Lee and Schaeffer theory, says phi plus beta minus alpha is equal to 45 degree. So what is the correct answer? What is the correct answer, dear? Tell me. Yes, 2 5 plus beta minus alpha is equal to pi by 4. Very nice, very nice. Very good, very good. See dear students, in the morning session today actually we were having the session on the electric arc welding. Tomorrow will be the session on electric, it will be on resistance welding. So like that we have scheduled for entire production. So do follow me on the Gradeup app. Do follow me on the Gradeup app. Very good dear, very good. Take the next question. So leap angle, when you talk about the leap angle of the single point cutting tool dear, how much it is? In the range of, it is in degree I am asking, in the range of how much? Leap angle I am talking about. This. Leap angle, yes, very good Shubham, very good Shubham. So dear, D is the correct. Sandeep, very nice Sandeep. Balaji, very nice. M Balaji, very good dear. So 60 डिग्री से लेके 80 डिग्री, 60 to 80 डिग्री. Chahat, very good. Chetan, very good. So please, dear all, 60 to 80 degree leap angle maximum. It is a range from 60 to 80 degree. Okay, it is general. It is a general range. Please remember this. Take the next question. Now the relief angles on the HSS tool usually vary. Relief angle. Suppose this is the workpiece and I am machining it, and say this is my tool. So dear, this angle, my relief angle. Okay, okay, relief angle. Question is like this: tool cutting forces with increasing cutting speed will be, options are increase, decrease. So dear, see, definitely we can say that, because see, when the increase in the cutting speed, there will be very easy flowing of the chip over the rake face. So there will the friction definitely automatically goes on down. So no any kind of forces from here to slide the chip. It will slide very nicely. Again, the material is deforming it very nicely with the higher cutting speeds. Okay, so definitely it should be reduced, you can say. Tell me this relief angle कितना होता है भाई? How much it is? Usually it is very less, from 3 degree to 10 degree. 3 to 10 degree. A is the correct answer. A is the correct answer dear. Not 1150. It should be usually 3 to 10 degree. Okay, if not present there, definitely there will be the friction, rubbing of the tool will, instead of cutting, the rubbing only there. Okay, that you know very well. Right, next. Negative rake angle is usually provided, already I told you. See, carbide tools, whenever the carbide actually comes into the picture during the Second World War, when the Hitler was realizing that the diamond dies which are used in the wire drawing industries are not so much beneficial, they are very costly. To optimize that thing, actually the carbide was get invented. Okay, it is by the German only, please remember. And actually it is as a tool material, it was around say 1960 to 1965, it was used as a cutting tool. Okay, so when it was used as a cutting tool, one thing is very clear, that dear students, the carbides are very strong in tension, but they are very weak in tension, they are very strong in compression. That is the reason why you need to have the negative. This is the negative rake angle dear, negative on carbide tools. C for Chennai. Chennai is correct. C, Chennai is correct. Very nice dear, very nice. Shubham, how you can say all these things dear? No, HSS, high carbon steels, they are generally given with the positive. Okay, they are given with the positive. Okay, carbides are very strong in compressive. Very nice, very nice. Take the next question. VT to the power n for the ceramics. If I say 0.05 to 0.1, 0.1 to 0.2, 0.2 to 0.4 and 0.4 to 0.6, and after that go for 0.7 to 0.9. So this is for high carbon steel, this is for high speed steel, this is for the carbides, this is for the ceramics, and this is for the, actually you can go for 0.7 to 0.9 for the diamonds. 0.4 to 0.6 ceramics, 0.2 to 0.4 the carbides. Okay, what is the correct answer? For the ceramics it is generally 0.4 to 0.6 dear. It is generally, if you say it is 0.4 to 0.6. So you can have here generally, if you take here 0.6 to 0.7, that is okay. Because from 0.7 to 0.9 we are using it for the carbon, so we are using for the diamond and CBN, diamond and cubic boron nitride. So 0.6 to 0.75, that is very much clear. Okay, very good. So not 0.2 to 0.4, you go for 0.6 to 0.7, that's better. Okay, that is correct. I hope it is okay. So please remember 0.6 to 0.7 you can take for this ceramics. More than 0.7 you can go for the diamond and CBN. Now tell me for this carbides generally it is 0.2 to 0.4. So in that range only we are having the option B, which is correct. Tell me the answer dear. So once metal cutting, see majority of the part we can have very huge topic, that is metal cutting. So today we'll discuss about it. Yes dear. Chahat Sharma, B should be correct. B should be correct. Nitish, B is correct. Nehal Ahmed, B is correct. Sandeep, B is correct. Very nice. Yes, very good. B is correct answer. Madhumita, very nice. B is the correct answer. Ankur, Jitendra, very good dear. Come on, take the next question. ये तारीख याद रखने की, you have to remember this date. 18 अप्रैल 2001, right? 18/4/2001. This is the very best example for, or the composition rather I will say, for the high speed steel. Tungsten, chromium and vanadium. Tungsten, chromium, vanadium. 18% tungsten, 4% chromium and 1% vanadium. Instead, in spite, if you don't want the tungsten, you can neglect that. Instead of tungsten, you take the moly. So it's either the tungsten based HSS or the moly based HSS. Very nice dear. This is the composition they have mentioned here. That is 18% tungsten, 4% chromium and 1% vanadium. That is right. Very good. Patel, very nice. Chandan Poddar, very good. Very nice. Take the next question. Which one of the following properties is not the process or possessed by the ceramic? Which one of the following property not possessed by ceramic? So ceramic is having very high hardness. It is having very high compressive strength. Also it is highly brittle dear. Only one property it is not having, that is the thermal conductivity, which is saying, they are saying high. It is not like that. A is correct, B is correct, D is correct, but C is not correct. Ceramics are having good hardness, good brittleness, good compressive strength. It is not having the high or good thermal conductivity. Very nice, very nice. All are correct. Oh my God, all are saying the very correct answer. C. Still now no one has given me the wrong answer. Very good, dear. Tell me. Okay, okay, go for the next. Adnan, you are laughing so much. Very good. Which of the following are the cast alloy containing the tungsten chromium carbide in the matrix of cobalt and chromium? Adnan, yes dear, thank you dear. Tell me the answer, tell me the answer. Now see, there is a HSS. Just now we talk about the high speed steel. So high speed steel generally it is having the limitation when we talk about when it is used for the machining of the ferrous. Because see, in that the matrix of this HSS is there, 76% around the iron is there. So that is the reason why it is not suitable for the ferrous. So for the same content like the hot hardness, the Rockwell hardness or the hot hardness temperature around 650 degrees centigrade, it is for the high speed steel. So the next development we have done, that is the steelite, which is known as the non-ferrous cast alloy. Non-ferrous cast alloy. Dear, please remember non-ferrous cast alloy. This is nothing but the steelite. This is the substitute when HSS is failed to cut the ferrous material. I hope it is clear. This is the steelite, which is the non-ferrous cast alloy having these tungsten chromium carbides in the matrix of cobalt and chromium. Very nice dear. This is the steelite, not the mehanite tungsten carbide backlight. These are wrong. D is the correct. D is the correct. I hope are you getting it or not? D is correct. D is correct. Nehal, very good. Ankur, very good. Very nice, Akhil. Very nice. Very good. Shall I go for the next? Dear students, come on, share this session, like this session, and do follow me on the Gradeup app. So there is also very good series is going on. Do follow the Gradeup app. I hope it is helping all of you. Take the next. Take the next. Ceramic cutting tool chip or fixed cutting tool chip. Actually, cutting tool only are fixed to the tool body by. In order to maintain the economy, in order to maintain the optimality of the operation, dear students, it is not necessary that I should use the complete tool made up of diamond, complete tool made up of ceramics, complete tool made up of carbides. Hardness for the HS is up to 650 degrees centigrade. For the steelite, it is little bit more. It is around 800 to 850. Anand Bade. Dear, please hear. So the very important, very nice thing that we have. So whatever may be your tool body, say it is made up of say carbon steel, high carbon steel, that is not a big deal. But only the tip I will make it as the insert. Okay. So that is the kind of paisa bachao. Okay, very good. Brazing, brazing. It is correct. Brazing is correct answer, dear. Brazing is correct answer. Very good, Savan Patel. Nice to see you, dear. Anand, nice to see you once again. So what is the answer for this? Chandan Poddar? It is a brazing. Okay, brazing. Generally we are doing brazing on the rake face of this tool. Okay. So we can have the bolt clamping also, but more feasible and very easy thing is that to have the bracing. Okay, very nice, Kuldeep. Here, Ajju, what you are saying that, see, friction welding, it is in the case of there is a circular bodies are there. For say example, if I want to attach the drill, okay, to the shank, okay, in that case there is a friction welding you can use, okay. Circular, that is very important. Circular symmetry should be there, then friction welding is okay, otherwise not okay. Thank you, Savan. Take the next question. Say, already I told you, the already answer is told to you. What is the safe operating temperature for the high speed steels? High speed steels. Yes, yes. Binding material is actually aluminum oxide. For if you talk about the ceramics, aluminum oxide. For the carbides it is tungsten, then diamond it is carbon, okay, like that. Tell me the answer for high speed steel, dear. Generally we never want the material or the temperature in the metal cutting zone go beyond the hot hardness temperature. The hot hardness temperature, that is the ability of the tool material to withstand with that temperature without losing the properties of the tool, say strength and hardness, okay. So that is very important here when you talk about the tools, tool materials. Say for the high carbon steel you can use up to the 250 260 degrees centigrade, HSS 650, steel light 800, diamond you can go up to 2000. More than that, if you can use the Yukon, Ceylon, no issues. Ceramics you can use up to the 1200, okay, like that, up to 1500 also. So the best safe temperature for the HSS is 650 dear. Beyond that it will lose its hardness, okay, the strength and hardness going to be get loosened, decreased beyond 650. So safeguard temperature for this HSS is 650. For the high carbon steel it will be 250. For the diamond and all it will be around 2000 degrees centigrade. Not a big issue. Not a big issue. Tell me the answer. Which of the following is the cutting tool material? Cutting tool material, of course, the high speed steel. Mild steel is not cutting material. Cast iron is not. The galvanized steel is not. Only the thing is that high speed temperature. High speed steel. High speed steel. Okay. I hope it is clear. See the temperatures, steel lights up to 800 degrees centigrade, HSS 650 degrees centigrade. If you take the carbide, it is 1000 degrees centigrade. If you take the ceramics, it is 1200 degrees centigrade. Diamond 2000 degrees centigrade, and cermet, that is combination of ceramics plus metal. If you go to that tool, it will be having the temperature, hot hardness temperature 1150 degrees centigrade. Okay, I hope it is okay, Chahat. All the temperatures I told you all the temperatures. HSS 650, that is correct. That is correct. Steel light 800, HSS 650, carbides 1000, ceramic 1200, cermet 1150, diamond up to 2000. I hope it is okay. And high carbon steel it is 250 degrees centigrade. Hot hardness temperatures, all the temperatures I told you. Is it okay? Shall I go for the next? Is it okay? See, so these are the plating is there, dear. So after that we are not going for machining for that. That is the main thing. So why should we? See, the question is that if I do the coating over that, okay, Ankur. See, I am doing the coating to safeguard my surface, okay. No. So the higher cutting speeds is go on increasing more than the steel height. It is at number 3. Okay, from bottom. So from bottom it is at 3. Okay, at the top there is a Ceylon. After that there is a Yukon. After that there is a CBN. Then the diamond. That is the sequence of having the cutting speed. Ceramics, yes, ceramics it is 1200. For the ceramics it is 1150. That is correct. I have written it here. Shall I go for the next, Anurag? Come on, dear. Tell me this answer for this. Which of the following is the hardest cutting tool material next to the diamond? Already I told you. See, I will start for the increasing order of writing the hardness, cutting speed, temperature, RC, all the things. High carbon steel, then the high speed steel, then the steelite. Okay, then you go for the carbides. Then you go for the ceramics. Then you go for the cermet. Okay, then you can go for the diamond. Then you go for the CBN. Then Yukon, and finally the Ceylon. Sayonara, isn't it? See, so this is the increasing order of all the hardness, cutting speed, hot hardness, temperature. Please keep it in mind, this sequence. So what is there after diamond? CBN, CBN. Very good, very good. The D is the correct. D is the correct. Dear, not silicon. It is Ceylon. Ceylon at the hardest. Yukon, see, you know what is speciality of Yukon? It can be rolled in the form of sheet. Yukon, it is a roll in the form of sheet. So I asked the question, which one of the following tool material can be rolled in the form of sheet? So it is Yukon. Which question nahi samajh mein aaya? Around the world. Which question? So see, these are the question. They are asking which are the hardest material, hardest material. Arey, how many times you are writing? I got what you want to say. Around the world. So see, these are the things I have written here in the increasing order of their hardness, their hot hardness temperature, their cutting speed. Okay. See how many times you have written there. So, okay. So you see, Nehal, it is okay. I hope it is clear. Okay, take the next. So optimum rake angle of the tool is a function of. Tell me, the optimum rake angle is a function of. So please, any typing mistake or button is get pressed there around the world in street mountains. Tell me, optimum rake angle of the tool is a function of. Okay, tell me. See, the rake angle here is depends upon how to choose the rake angle. The very best thing is that the properties of the material is going to decide. The properties of the material that are going to decide the rake angle. What should be the rake angle for that particular material? Okay. So dear, yes, C is the correct answer. C is the very correct answer. Dear all, C is the correct answer. Not A, dear, not A. There are the properties of the work material that will decide the optimum rake angle. Okay, C is a very good. Chalo bhai, next. Tell me the answer for this. Tell me the answer. The friction between chip and tool can be reduced by. That's very nice. Bypass this passage for sliding. Okay, so I told you, see, There is a tool rake face over which the chip is sliding and moving. If you want to slide it very fastly, so definitely go with the higher cutting speeds. Yes, increase the sliding velocity, isn't it? Go with the high speeds. Definitely the chip is also coming out and moving away from the metal cutting zone very fastly, and so the friction cannot do anything there. Okay, so I hope it is clear, dear students, and I hope you are enjoying and you are learning also. That is very important. Our intention is that to make practice of maximum questions from you guys. They're very good, Ankur. Very good, very good. All of you are very nice and excellent student, dear students. You are excellent, okay? And very extraordinary is Adnan. Okay, very nice, Adnan. I hope this is okay for the today. This is okay. This is done from my side today. Tomorrow we will be meeting at this time again. Once again, we'll be having some again nice questions. Thank you, Adnan. Thank you so much, dear all. Thank you so much. Because of you only we are getting this energy. Okay, so do join these sessions tomorrow also, and do follow me on the Gradeup app. And definitely we are going to see again very good questions. See, these are the very simple basic level question. Definitely we are expecting. So for that we have the maximum practice. Okay, thank you. Around the world in street mountains. Tomorrow I am going to see you there. Till then, thank you so much. Thank you so much for joining. Good night. Take care, dear all. Thank you so much. May God bless you all. Thank you so much. Bye bye. Tomorrow again at 8 p.m. Tomorrow 8 p.m. Don't forget, 8 p.m. we will be meeting. 8 p.m. Thank you so much.